All right, this is on lesson 16B. In order to test our hypothesis, we need to have evidence based on our decision. The evidence comes from collecting data from a sample and then calculating statistics. So what we're going to be talking about is the student's t-test. So a test statistic summarizes the information in a sample. So we've already talked about, in our prior lesson, hypothesis tests. Does the mean equal the sample? So if the hypothesis, the null hypothesis, true, then we would expect there is a difference between the mean of the sample and what you actually collected to be close to zero. So a suitable test statistic should include the mean minus what you collected. However, the mean minus what you collected alone does not take into account the variation of the data. If the standard deviation is also very small, a value of the mean minus your sample close to zero is likely to happen simply by chance alone. The test statistic should therefore involve a sample standard deviation S. So this is the formula we will be working with in this blue box. So consider that hypothesis test. Given a sample of n, so that's your sample size, how many items you collected. Then you have your sample mean, your average, and your standard deviation S. Those things will go into this equation. You will not have to memorize that equation for your t-test. So this is the formula for your t-test. So we're going to go ahead and look at this example. So consider the insect repellent example from our previous lesson 16A. Suppose a researcher took a sample of 50 bottles of insect repellent. The new product and found that the mean protection time was 6.12 with the standard deviation of 15 minutes or 0.25. So you're going to substitute into this blue formula your mean, your null hypothesis. Having issues with this iPad, and the standard deviation, and then the sample size. So if we look below, we get a value of approximately 3.39. When you take the IB exam, you will not be required to calculate this by hand. We will be using a graphing calculator, so we'll show how to use this on another video. You can click on this icon, so we'll show you that icon in class. Now, suppose a population is approximately normally distributed, so your bell curve. The distribution of t-values from a sample size n is t-distributed with n minus 1 degrees of freedom. So this is how we write it. So the t-distribution is slightly flatter. So here's your normal curve. And then there's your red curve, which is your t-test, is a little flatter as the sample size and therefore the degrees of freedom increases. The shape of the t-distribution approaches that of, this is your mean, and then your standard deviation. So we will pause there and create a new video for this.